All right, if you want to drop down now, I want you to do sound check. I'll be around for a few minutes. I did a sound check already. The song got on the set. I just fired the stream. Give you Beerman. Heck.
Geo, are you there?
Yep, I'm here.
I got a question for this discussion tonight. I've got some videos that I don't have them on YouTube. I just got them on my PC. Do I need to upload them now already, or should I first upload them to YouTube and share them that way, or would it be fine to upload them here? Or should I share my screen, or how's that gonna work?
I'm sorry, I just came into this. I was in the kitchen. I think that sharing your screen is going to be fine. I think that, I mean, uploading it to me is just time that you don't need to spend doing that, I don't think.
Okay, cool. Yeah, it's just
Yeah.
that some of my experiments that I obviously haven't shared with anyone yet, which I'm obviously going to share now tonight. But yeah, I just wanted to know which way I should get it there. So yeah, then I'll share my screen then. That's cool. Do
Yeah.
I have those roles and all that?
Yep. Yeah, you've got the screen share role, and then I gave both you guys the guest live stream host role. So basically, the way it'll work when people first join here, they're just going to be muted, automatically. And then if you guys want to unmute someone, basically click server mute twice. So you want to basically just remember to do it twice. Just basically mute them, unmute them the first time. That basically unmutes them. So just do it twice. And then once you've done that the first time, once you've clicked it twice just the first time, then after that you'll be able just to sort of mute, unmute with the server mute if needed. I don't know how much you guys are going to use that because you'll probably be more of a discussion, but that's but you'll have that if needed.
Okay. Yeah, so basically what I'm going to do is I'm just going to present my whole thingy that I've put together, and then I think we can do like a questions and answers discussion thing from there. But I think let me first get all my stuff out, if you don't mind, Travis.
Oh yeah, no worries, man. Yeah.
Okay. And
Yeah,
then
so it all seems good. I mean, we're live right now. Actually, I have the stream live, so I'm just gonna leave it live. I don't know if I'm gonna be here right at that time. I'm kind of in and out, so I don't know if I'll be right here. So I wanted to get this all set up now. So it's running live, and then later, afterwards, I can cut out the, if there's a couple hours of dead air, I can cut that out, later. But yeah, I mean, it's live right now. The audio's up, and then I created an event page for it as well, so that it's listed. I put the link to that as well in the chat.
What's that mean?
Tagged you guys. Discord basically just has this event feature thing where up at the very left, at the very top of the Discord, right now there's 2 events. So there's always an event.
I see it. Okay.
There's always an event running for Livestream 1, and then
I got it.
so it's kind of cool because people can see it up at the top. They can click join. They can, and then you can share that link as well. Like if you want to share that link, you can share it, and then people can join right from it. You can share it on Discord, and it'll pop up. So like if you want to invite anyone from Discord, just send them that link, and then they'll be able to click that and either join the server or join the VC directly. So yeah, it's just this little like events feature that Discord has.
Fun.
Nice.
All right.
And then I just put in Livestream 2 the one that's live right now. Oh, it looks like I didn't put a thumbnail. I'm using the one that says Livestream 1 for a thumbnail. That's all right. I could fix that later.
I'm just going to test the screen sharing quickly to make sure I get this all right.
Yeah. I kind of want someone to join here that just to make sure they're muted when they come in.
Okay. I'll hop out and go to the other server and see if somebody will come over.
The other room, you mean?
Yeah.
So let's see. So you can see my screen now, is that correct?
Yep. Yeah, I can see it right now.
Okay, I was going to see if I play this video. Do you see that video?
No, I don't see the video at the moment.
Because that is playing. Okay, hold on. I'm going to stop this screen share and I'm going to try another one.
Travis, we actually don't need anyone from up there. We can do it ourselves. Did you already try to recruit someone?
Yeah.
Do you see it now?
Because I could actually do it with yours. I could just remove the live stream host role, and then you could just.
Oh, I see. Yeah, I get you. Yeah, I got it, Beerman. Yeah,
If I play, you actually see it?
yeah. I can
Let's see it now.
Okay,
Yeah.
cool. Okay, cool. So that's how I got to do that. I was going to try something else quick.
Yeah, I mean, if you want to, nobody's jumping down here. If you want to do that, Geo.
Yeah, just try it right now. Just leave the room and
Want me
then
to
come
drop?
back.
Okay, all right.
What do you see on my screen? Am I still? No, I'm not sharing. Now you should be able to see a bright purple blue sky. Is that correct?
Yep. Yeah, I can see it.
Okay, cool. So then I know how to work that.
Yeah, all looks good.
Okay, fantastic. I've never done something like this before, so I just want to make sure I get everything right.
Yeah, it's working, Travis. Yeah, so you joined, and yeah, you can't unmute, and then I don't know if you guys are on PC or on your phone, but so for example, Travis just joined. So anyone that's like live stream verified or voice verified is going to be like Travis is right now, where he came in as muted. So if you wanted to unmute him, you would just right click. I guess you only have to do it once. So he's automatically server muted. So you would just never mind. The thing I said, clicking it twice. I guess you don't really need to do that.
Yeah, I figured we would figure it out. I didn't think you were right, but it's not that difficult to see.
Yeah, it's just a tick box. I see a tick box on desktop. Yeah.
Right.
It's just the red one. Yeah, the server mute one. All right. Yeah, that works. That
Sweet. Yeah, that's great. That 2 events thing, because I'll use that for sharing.
Yeah, it's pretty cool to share it. It like looks pretty cool, and it shows up on, and then they can just join right away. And actually, the event's not started yet. I could probably just start it now. It doesn't really make a difference, but I think it'll just show that it's live. So I'll do it right now. I'll just click on.
If you're not going to be, Gio, if you're not going to be during this presentation, I highly suggest you do watch back at it, because I got some awesome finds and some awesome stuff to look at.
Nice. Yeah, definitely. I'm just not sure if I'm going to be able to be here right at that time. Depending on what time you guys start, I might be kind of in and out. But yeah, I did want to get all this set up now because I do have a little bit of free time right now. So yeah, I'm glad we were all 3 able to do it right now. It's awesome. But yeah, no, definitely. If I don't catch it live, then yeah, I definitely want to watch it back, and
Gonna leave you scratching your head and hopefully blow your mind.
Nice. Yeah, so I just started the event. I guess it just says live now is the one difference, and I think it pops up at the top of the server too, and it says live. But although now it doesn't say starting at the 1 p.m. time, but either way, yeah, it's not super important. Unless we want to leave it unstarted and just have the time on it. Yeah, maybe I'll do it that way.
Yeah, leave it with the time rather.
Yeah, because that way people, yeah. Actually, I don't know if you can. If you could stop it after it started.
All right. I cannot multitask when I'm listening to something like this. I end up just listening and meandering and not doing what I'm going to do, so I'm going to drop out.
Cool.
Dude, I'm the same way. If I'm trying to read something while also listening, I was like,
yeah.
Is there a way I can share my screen where it'll pick up the whole monitor? I'm just trying to figure this all out. instead of me having to drop every time. Oh, there we go. It says applications or screen 2 or screen 1.
Yeah, I think you can pick like if you wanted to share your whole monitor or if you only wanted to share a window.
Okay. I just want to make sure I got all this stuff right. We also got the shitty thing in South Africa called load shedding. So where they switch off our power for 2 to 3 hours. So I'm just charging up my UPS battery, or not UPS, my inverter's batteries and that. But I should be good.
Yeah, they shut your power off. Is that every day or?
Yeah, at the moment it's every day, like 3 times a day.
Wow.
You don't have to check this, I'm just testing.
All right, I fixed the event. I just made a new one, and then now it says starting at 10 a.m. So anyone who wants to see it will be
Okay.
able to see it. Well, 10 a.m. my time, but I'll post it in the main chat. All right. Well, yeah, I think you guys are all set.
Yeah. I'm just messing around here with the screen share, making sure I'm doing this correct.
Yeah, I'm always a little bit cautious when I share just to make sure that I'm only sharing the window I want to share.
Yeah.
Not that I have anything too private or anything, but yeah, I just don't want, something. Yeah, so it's always like you got to be extra careful with every click just to make sure you share the right thing.
Yeah.
All right. Well,
Cool.
yeah, I think Travis said he's going to record it as well. And then I'm going to leave this one running. Like I said, if I'm not here, then yeah, I mean, worst case scenario, if the stream goes down or something, but Travis is going to be recording it, as well. So even if that happens, there should be backup
Yeah.
in terms of his recording. But yeah, it's live now. And then the event page is made and you guys got the roles you need. So,
Nice. Cool. Well, then we'll see you later.
all right. Yeah, sounds good. I'm looking forward to hearing it. And yeah, if I don't watch it live, I'll definitely watch it back. And yeah, I'm looking forward to, because yeah, some of the conversations you guys have been having the last couple of days has been some good stuff. So yeah, I'm looking to see what you guys got.
Awesome. I'm still going to hang around in here, but I just want to make sure I'm sharing everything correct and what's popping up is the right thing and stuff.
All right,
Cool,
sounds
man.
good. And yeah, just send me a DM if you need anything.
All right, cool.
All right, cheers.
Cheers.
All right. This.
Hi, Travis.
Hey, hey.
I'm still eating, so I mute again. Okay.
Yep. Next streaming software to go live. I don't understand what the crack is wrong with YouTube. What am I supposed to do? Start sending us your video. I don't even get it. Okay, I think I'm gonna have to stop that over. Whatever, I guess I'll find out.
Travis, you there?
Yeah, I'm here.
Okay, cool.
I was having trouble with YouTube, so I had to restart my stream on YouTube, but I'm here on Discord.
Okay. Well, you let me know when you're ready. I switched my push to talk off because it's going to be difficult for me to do all the screen swapping things and that on push to talk.
Okay.
But yeah, you let me know when you're ready.
All right. I think I'm just gonna start my stream. I have an intro, but I'm just gonna stop it and start. Hello. What ho! Welcome back to another exciting adventure of The Plain Truth. I'm your host, Travis Finlay, here with some fellow Ether bandmates. What's going on, everybody? Say hi, check in voice-wise if you want to check your voice.
What's up, Travis? Beerman, yeah?
Check.
Yep. So that was Skylane there. Got some people in the chat hanging back. You don't have to say anything. That's fine. But I am... Let's see. I should make sure my YouTube's going. Okay. Sounds like YouTube's going good. I think it's just when I try to stream my intro, for some reason it buffers like crazy. So yeah, we could just jump on into it. Beerman, it's all yours, man.
All right. Great stuff. So I'm going to start from the beginning because this is going to be a presentation that's going to be recorded. And yeah, let's not start in the middle of something. Let's rather start from the beginning again and go from there. So can you see my screen that I'm sharing?
I've got it pulled up. Yep. Got your mouse.
Cool.
Yep. Yep.
Perfect. So you can see my mouse as well. That's great. Okay. So first thing I want to mention is I'm going to use a name or a word that I use often is going to be called a focus point. And it's, you guys will probably refer to it or know it as a vanishing point. So I'm not too finicky with words. I know some of the guys get very deep into what word meaning, what the meaning of words are. But when I say vanishing point or focus point, I'm talking about one particular thing. So if you see this, let's have a look at this image here first. So I'm referring to this image here, which I'm going to also reference with this top view and this bottom view or side view image here. So if you look at this image here, this is actually one of Travis's images that he's taken. And you'll see this water line over here, or the water over here, and then you'll see the land image above here. Then you will see this weird merging, stretching phenomenon that happens, and it'll sometimes look like a mirror. It'll sometimes be stretched. It's just, yeah, it's a distinctive spot that's on all long distance images that I've seen. I haven't seen a long distance image where I don't see a waterline and a piece of land, I would say, merging smoothly with each other. There's a distinctive line between the two, or cut between the two. So what I am suggesting is, or what I'm starting to pick up is that this water that you see at the bottom here where I'm with my mouse, and this line here where I'm going across with my mouse, this water and this image here are two separate images, but in the same focus, and that's why we're seeing this. So what I'm suggesting here is that imagine, oh yeah, I'm actually going to explain it over here. So if we're looking at this top view, so in red, these aren't exact angles. These are just a basic illustration of our viewpoint with no zoom, just you looking straight ahead. This is a top view. You in the center here, this is your visual perspective over here, from left to right or right to left. It works the same way with up and down over here, but we're going to focus mainly on this image here. So what I'm saying in this image is this, in this circle here, this is our current atmosphere conditions. So you go outside, this is what I'm talking about. But further down, the further you look, the atmosphere gets thicker between you that's standing here in the center, and let's go right to the end here. There's going to be a lot more atmosphere in this region. So my suggestion, what I'm saying here, what I'm claiming is that if we take a camera and we zoom, and that's this yellow line here, we zooming to this point here, and I'm calling this the focal point. If I show you this image on the right, this is going to actually show you these lines what I've drawn here. So here we're standing in the center where my mouse is. We're zooming in, and now we're seeing this image here. This focus point is this weird thing that goes on here. So I'm calling this the focus point. And the reason why I'm calling it the focus point is because this image above and this image below are two separate images. And the reason why we're seeing this here, I'm claiming that this is a lens magnification, and I will explain that later in the presentation of how I get to this conclusion. But I just want you guys to understand how I'm getting there and why I'm seeing this. So I'm going to say it again. We're standing in the center here, all 360 around you. If you go outside now, you will clearly see there's a place where the land or your bottom part of your view will get to a vanishing point, which I will now call a focus point, which is that snap piece over there. And I'm claiming that this circle here gets bigger and smaller depending on the atmosphere conditions. I have got a little experiment to also show how sunsets will work on it. It'll explain all of that. But have I made that clear? Because to be honest, I am quite nervous doing this presentation. I've never done something like this, but it's something I've been working on for about 7 years. So is everything clear so far? Should I try again there? Can you confirm that that's all good?
Well, I mean, to be honest, I'm taking it in for the first time too, and so I am trying to process what you're saying. I don't mind if you try to go back and say it again. Now, when you've got that center focal, well, not the center focal, but when you've got that observer point right there, right where your mouse is, there's going to be, well, so if I'm looking straight ahead at the house, if I did a 180-degree turn, I'm not going to see the inferior mirage because there's a completely different topography behind me.
Correct.
So I'm trying to think through it that way, because when you talk about a 360 view, blah blah blah, but
I can explain that. No, 100% I can explain that.
Okay.
So I will pull up an image or a few images actually to show what I'm explaining, or I can even show it on Google Earth because you'll be able to see it on Google Earth. Or do you want me to do that first, or can I go ahead and
do whatever you want?
Okay. So you'll see here I've called this Atmos conditions. So I don't want to use the word sphere, for instance, and then I get called out for that. So I'm just calling it Atmos conditions. So I'm saying these are different rings, and you got so how I get to this circle getting bigger and smaller is because you'll notice that this focus point, you've actually got a fantastic image. Let me get that one up here. Wait, it's. Did I save it in here? No. It's the ones with the. Wait, let's just stick with this. Where you'll notice that this line here, and let's go back to this image. I'll see if I can find that image now. But that line that I'm got my mouse on now, you've put that camera in the same position, and that line moves higher and more towards you, so it goes further away and closer towards you depending on the conditions. So I'm claiming that that's this circle getting bigger and smaller, and that magnification is changing.
Okay.
All right, and we'll see that on an image now, or on a video as well, that I'm going to be showing later. So that is what I'm showing here with this yellow is your actual camera zoom. You zooming in to that focal point. And the reason why I'm saying that, or you can go grab a 1,000, like a P1000, and you can go grab a telescope that can zoom further than the P1000, for instance. But you with both those telescopes, or that sort of telescope, I'm very bad at my words, that telescopic, for instance, device, you're always going to see this like this. You're never going to be able to zoom in onto that house and see what's in that window. You'll always see it in this sort of focus point. You won't be able to go into that. You won't be able to zoom into that house. You'll be able to zoom into this water to see maybe there's a fish in that water, but you won't be able to zoom into those windows. You're always going to get to this focal point. And that is where you'll see this, what I'm calling this focus point. That's this line that we're going to see here. So I'm going to move on because the next few images will explain that better. You'll be able to see
Can
what
I back
I'm talking
up just
about
real
better.
quick for clarity?
Yeah, sure.
Go up to the top left image.
Yeah.
Is the focal point for you where the water ends or where the mirage begins, where it starts to differentiate between, right there? Is that the focal point?
Yeah, for me it'll be between on the top where my mouse is here and over here. This will be the focal point for me.
Okay.
So sometimes that focal point is very narrow, sometimes it's very wide.
Yeah, exactly, and that's what I call the ether band. That band of visual space. Yeah.
Okay, so I'm going to show you the ether band where it'll be that same place, but it'll be much wider. I will show you where this goes all the way around you, from here to 180 degrees right behind you. It goes all the way around you, and I'll be able to show that and hopefully be able to prove it. as well, with a basic little experiment that I've done. And this lensing, yeah, so like I said, there's that line. This is a lens. This is a projected image. You cannot see through this. You cannot shine a light through here. So when so you literally cannot even. You can try send a light through there. It might go somewhere, but there's no tool that can see through there. You can take an infrared camera, and you will see the same effect happening. So you cannot see through that, this lensing effect. And let me show you here at the bottom on a side view. So let's say, this is where you're standing. This is your current atmospheric conditions. This is where you see in focus. So you say you jump into a swimming pool, you can see that far in the swimming pool, then it becomes a complete haze. Does that make sense? So
Yep.
that's where you are here now. Then you're getting to this point here, and I'm between where my mouse is now, and this point here where my mouse is. I'm saying there's a lensing effect happening. So, and all of this in this pink area here is, with that amount of water vapor, is creating a magnification. So everything within this magnification is getting brought forward to this line, which is what I'm calling the focal point or focus point, also known as well, it can be the vanishing point as well, because this is where everything vanishes to that point right at the bottom here, and everything around this here is your focus point. That is in focus, and that's why you can zoom in to this specific position, and this position changes according to the atmosphere conditions. And that is also provable, in my opinion. I don't think you can disprove that. Because you cannot zoom through there, you cannot you can shine a light through there, but you don't know what's actually going on this side because you cannot see what's on that side. You just cannot see through what's on that side. You can see what's projected here on your focus point, but you cannot see through it. There is a basic explanation here, which I want some of the guys to help me word this a bit better, because as you guys can probably, I'm not very good with my wording. But let me show you, for instance, here's a video of this specific effect happening.
Make sure the audio's turned off, please.
Yeah, audio's turned off, don't worry. So I have fast forwarded a bit, but you guys can go back and can confirm what I am showing here. Can you see the video?
Yep.
Cool. So this boat here is traveling away from us. All right. As you can see, it's traveling away from us. It's not going towards us. It's going slightly to the right, but it's traveling away from us. Can you agree with me there?
I can.
Yeah. Hopefully the audience can also agree with me there. But there's going to be another video that's going to show my point that I'm going to make now as well. But if I fast forward this video, it's still, as you can see, it's supposed to be going over this. This is supposedly the curvature of the Earth here, the horizon. But it's staying on the same level. In fact, I don't even think it's in the bottom image anymore. I think this is already in the I'm saying it's already in the magnifications view. So we're actually not even seeing a physical boat there. We are seeing a projection of a boat. You can shine a laser onto that, and I don't believe that the laser will hit that boat. I'm going to fast forward. Yeah, you'll see it go past this buoy, but that buoy is in the bottom image. It's not in the lensing image, and that's why you see that depth perception. And I'm going to fast forward here to 7 minutes.
Can I stop you just real quick?
Yeah.
So there's a lot of graininess in your video. I wonder if you can try to up the resolution. I don't know if that's going to be able to be done or not, but it's really grainy. Is that from?
I think it'll be my upload speed that's the issue. Yeah.
Okay. The other thing that I'm troubleshooting right now is on YouTube. Your shared screen is not being seen. So everything that you've done so far has not been on Geo's stream, and I'm trying to figure out why that is, because I've got your video pulled up. I can see it. I think I'm trying to figure out if there's something. You know what? If Geo.
No, so I noticed when the guys do share their screens on the live stream, you don't see it. But what I will do is I'll leave the links to all the videos in order. and a image of that
Yeah, and
magnification drawing.
if anybody's listening, obviously you can come over to my channel and it's going to be on the live stream for that. But I just was trying to figure out how to troubleshoot this. So I guess that there's no way to do it. So let's see. And the other thing that I can't do, if anybody can help me figure out, maybe I can figure out how to pop the. I'm gonna try to figure out if I can pop out the live stream chat because I can't see the live stream chat right now in Discord. So like if somebody wanted to say something and ask you a question,
Yep.
I don't know. So I was just trying to think if anybody knows how to do that. I just don't know what to do. So
Is that on the YouTube side or on the?
no, this is on the everybody who's in Discord right now, like Bozo, Lightwater, Flatty, Skylane, Tim, they're all in here. I'm assuming they're watching you. So I just want to make sure, Tim, anybody else, can you guys give me a thumbs up on the video if you're watching Beerman's live? You guys okay with that? Everything working out? I just don't know how to see the live stream chat if I have the window blown up as well. So I might just have to let that part go. Not worry about it. Okay, so Tim says he's good on the presentation. So they can watch your presentation. I suppose that's the yeah, I just wish that the live stream that's live right now would be able to see it. Because what's on the live stream right now is just the chat. I would think that there's some way for Geo to switch the live stream presentation instead of the chat. Let me see if I can message him real quick. I apologize for having to interrupt you.
No problem. Gives me a bit of a breather, calm my nerves.
Okay.
It's never showing normally, Travis. If there's a live presentation in VZ1, it's also not displayed on YouTube.
Okay, well, just carry on then. Carry on.
So on that video, and yeah, I do apologize for the grainy video. I can make it smaller. Does that make it a bit better? Check that. Or is that still very grainy?
Well, I don't know. Lightwater, what do you think?
I was dimpled in thoughts because I already stumbled on something that I don't totally agree with. So, and that's the stretching up mirage part will also be visible in infrared.
Okay.
Infrared takes away almost all reflection, not completely everything, but because, for instance, in the Pyrenean mountain towards the Alps, there is some reflection in the water, but most of it is totally black, and that shows that it, for a big part, takes almost all reflection out of the atmosphere and the water.
Okay, well, let's hold on to that toward the end. I think maybe it'll be best for if you do want to make a comment, take notes, or maybe even just put it in the chat. We'll go back and look through the chat if you want to leave your thought there, if you don't want to lose it. So I think that's a reasonable discussion point for us to have, but maybe at the end of the presentation. Yeah, just leave it full screen. Beerman, that's fine.
All right. So I'm playing here now again. So I just fast forwarded a bit because it's going to take a while, but you can go watch this video. It's not that I'm skipping anything or cutting the video short. I just want to fast forward to get to this point here. So as you will see, this looks like the boat is going to go past this buoy on the right. But look what happens. It actually goes in front of it. And I'm going to pause it again as it goes past it. And you will see it's going to come back in front of it. So this is why I'm saying that this is a projection, this is a lens, this is magnification. These are all in one magnified view. You cannot zoom into that boat to get a better view of that boat. You can make it bigger, but you won't get better view of it. I'll carry on playing the video. That's basically just the point I wanted to make on that video. In the next video,
Just a quick point of clarification. I want to try to understand if what you're saying about the buoy.
Yeah.
I know that visually it kind of looks funky, but physically the boat is in between the buoy and me, the observer. Or are you trying to tell me that you think that the buoy is closer to me?
No.
And
No, that buoy is further from you.
Right. So when it gets to the end, I'm not sure, because when it got to the end, to the left of the boat, you said it's now in front, I was confused.
Can I say something? Can I say something? The boat is going through the water and disturbs its own reflection in the mirroring image, and that's why it looks and the buoy is silently in the water, so it reflects itself farther away. So that's my assertion, my assessment of it.
Go ahead.
Okay,
Beerman.
we'll get to that in the end. So I'm saying that buoy is now in front of the boat.
Yep.
We haven't even reached it yet.
Yep.
But you'll see now that it appears that it comes ahead of the image again. There now it's ahead of the boat.
Apparently. Okay,
Yeah,
I got you.
yeah.
Okay. I'm good.
All right, cool. So that's what I wanted to show in that video. There's plenty of these sort of these videos around as well that you can go through. I just like to use this one. I'm going to go to the next video now with this ether band. With the graininess, you're probably not going to be able to see it. But this is just a nice clear one
That's
for
not
me.
bad.
Is it not too bad? Okay. So here's where I'm saying that focus point, where my mouse is. And just actually below that, it'll be about here. So everything above that, I'm claiming is the lensing effect, and you actually not seeing that. That is a projected image through a magnified lens, and which I'm claiming is the atmosphere that's creating that. And this, you can clearly see there's something moving from left to right, which is I would say the only way to refer to that now is what you guys are calling, what we're calling is the ether band. And I'm claiming that goes all the way around you, 180 degrees, so 360 around you, 190 up above your head to your back. And I will show you why I say that as well. So that is what I'm talking about here with that ether band and the lensing effect. So you zooming in and you seeing the water in the same focus over here as this actual projection, you're seeing it in the same focus. So you can zoom in and you'll only zoom in to this point. You can't go through this actual band that's going across here. So that's what I wanted to show on that video. Here's a mirage. I call this the treadmill, because here's where, let me make this bigger. Here's where that focus point is again, and then the miraging starts, and then these people are all on a treadmill. You'll see there's a bicycle guy here. He's actually cycling. He does eventually get to the end of the I call it the treadmill, but this little video. But you'll see these people are walking in the same spot. They are not going for. They will eventually get a bit further away, but for quite a while they walk in the same place. This lady, she's having a great workout on the treadmill. So that's another lensing effect, which I'm claiming.
Well, you can see it with the farther people too. That couple in the farther distance is doing it even more so. Same
thing. So, and you'll also see that there's a band that goes from left to right over there. What you can also so when I claim that it's going all the way around you is same with the sun and moon stars. If they are at that distance, so your aeroplane won't be in that distance. But let's say that band, if we measure from your visual point to, let's go get this image open here again. If you measure from here, from your center point where you're standing with a camera, with a telescope, whatever, to that focus point, and you go 360 around you, that distance, it will change a little bit when you go straight up vertically, like from this section to up here, because the atmosphere gets a bit thinner up here. So the lensing effect will push out. So this dome will come a bit, I don't like to use the word dome, but let's call it a dome now that you can see what I'm talking about. But this dome will be a bit higher. It'll be more like a just a higher dome. But these distances from here to here and from your center to this side and forward and backwards will generally be the same distance away. And when we see the sun, moon, and stars, we are seeing it on this band, this focus point around there. And I got a little test that you can do as well. I actually made a note here. If you take two objects, one smaller than the other, so let's say you take a remote control and a lighter, so a cigarette lighter. You hold the one further away from you than the other one till they look about the same size next to each other. Okay? And you zoom in. They will fill up that camera lens the same size. Does that make sense? So if you zoom into the object further away and you zoom into the object closest to you, they will be the same size. Even though they're different sizes, if you hold them together with each other, then you'll see the size difference.
In the same frame?
In the same frame. So you holding with your right hand, you say you're holding the cigarette lighter, and you're holding the remote in your left hand. The cigarette light, the bigger item will be further away from you. You will hold it further away from you, and the smaller item you'll hold closer to you. Does that make sense?
Yeah, but when you zoom in, they're going to even out.
Yeah. So if you zoom into either one, so you zoom into that the furthest item, it'll fill that camera. If you max zoom into it, you'll see the same size item if you max zoom into the smaller item at those distances apart from each other. Do you see what I'm saying? Do you understand what I'm saying? You can test it. I tested it before I made the claim as well. So what I'm trying to do with that little observation is, if we see that focus point on the horizon, say where the sun sets, where you generally do see that focus point, we're going to get to sunsets after this as well now. But if you get an object, if you look at, for instance, a little mountain in the background, or not a little, a big mountain in the background that looks more or less the same size as the moon or the sun, and it looks about the same distance as where you're seeing that focus point happen, you can zoom into that mountain and you will see the same amount of object. So that mountain will be the same. I'm not claiming that the moon is the same size as that mountain. I'm claiming that the projection is the same size as that mountain. Because you zoom into that mountain and you zoom into the moon, you get the same amount of visual object in your max zoom. Do you understand what I'm saying there?
It would help if I could see it, but go ahead, keep going.
Yeah. Okay. I will try put something together to explain that then better. But yeah, what I'm trying to say is that I'm thinking that this focus point is, let's say, plus minus 20 to 30 kilometers away. It does depend on atmosphere conditions, but yeah, that's where I'm claiming you're seeing the projected moon and sun and stars and so on and so forth. Let's do an example here. Oh, wait, let me first give you the meniscus video. Okay, wait, let me give you angle drawings here. I just want to get this open. So, this one will probably be okay. There's 3 different ideas I am working on. They're all very similar. I do think that this one I got in front of me is the one that's actually happening. So what I'm showing on this image is, what did I write here? Narrows curve. Sorry, my spelling was a bit bad there. It's supposed to say narrow curve causing a narrow focus point. So when that focus point is at a certain distance. Sometimes you'll see on my meniscus video that these corners here where the focus point or vanishing point meet with this ether band or whatever is going around you here, that focus point, these sometimes appear to be narrower like this with less of a angle or curve, which gives us a thinner band line before the lensing effect happens.
Can I
some
stop you
days-
real quick?
Yeah.
What does the circle on the left of that dome represent? Is that the viewer's position, or is that the field of view on the left of the? So the picture that we have on the right is the platform.
Yes.
Okay, so
So
if we overlay that dome on the platform, is that what you're describing? The left side of the photo where the
No.
circle is?
So
Okay.
I'm saying, so if you looking straight towards that dome, I'm taking a side view now.
Okay, that's the orthographic.
This is
Okay,
side
so on the far right, that's where the target is of the dome.
far right. So you standing in the center here, and this platform is over here, or it's we seeing it actually on this lensing here. I'm saying you're seeing it on this projected lens.
Okay, now I'm confused.
Okay. So we looking from here. We in this. Let's go like this. We standing here, and we looking down here onto this focus point. But now
Okay.
remember, this is coming over us here. So we looking at that point there. That's what I've circled.
I think I'm understanding you now. Okay.
You got it there.
Mm-hmm.
Okay. So these angles, I'm saying, is what's causing these bands over here to be larger and smaller,
Mm-hmm.
depending on the distance, the atmosphere, and you will see that in my meniscus video as well. That's coming up.
Okay.
So depending on that angle, will cause this to be wider or smaller before you actually see the clear magnification lensing. And this is also why I think we're seeing these inverted mirages happening. I think that's a reflection happening on this downward curve here as it comes up, which you will see in meniscus videos or meniscuses as well. So here's a more severe curve around. So this will be a much bigger, for instance, meniscus,
More obtuse,
and you'll see a larger reflection, and then you'll see the clear, crystal clear, or not crystal clear, but clear lensing magnification on there. So that's those angles, and that's how I'm probably the correct word is claiming that what these are or what's causing that. I'm sure further research can either confirm or debunk that. Let me have a look here. Let me show you the meniscus video. So this was a little demonstration. I tried to, this is how I came up with a lot of my ideas and how I got to where I am. I will, in the end of the video, explain to you guys how I got to this whole model. But yeah, this is just a basic little experiment you can go test yourself as well at home. It's with a glass of just a glass with water in it, creating a meniscus. And I'm going to be showing how the sun could work with this. There's no audio in this video. Let me just rewind. Yeah, sorry. Let's go back. Is this video clear?
It's a little bit grainy, but it's fine.
Okay. So I'm just stopping here so you can see there's a meniscus on here, and along this edge here is what I'm calling, those are those angles that I'm talking about. So depending the height of this meniscus will determine the actual those angle severities, which creates those mirroring and stretches. So you'll see the effect it has now with the light. Actually, in this video, I didn't even think it's going to happen, but it happened. It looks like the sun is bouncing around in this glass, but let's have a look here. The sun is, I'm using my cell phone torch as a light source, which you'll see in this video. Now watch how this little sun looks like it's bouncing around in the glass. You see that? It even creates a little shadow. But now, I'll just tap the glass so you can see that it's not CGI or anything. You can test this yourself. But now I want to show you how sunsets could work, or sunrises and sunsets. So have a look how that little light. Yeah, it's probably too grainy to see, but it looks just like a sunset would stretch out, bend, and do crazy things like we see, depending on the atmosphere conditions. And there it comes, and there it goes.
Well, you're gonna have a. Okay, go ahead. Just keep going.
Okay, so this video I'll also make available for people to see. That will be a lot more clear. I'm just pausing here. What I wanted to say was you'll also notice on some sunset videos is that sometimes it looks like the sun is hanging there in one spot, and it's just taking forever to go down. It got there quickly, but it just doesn't want to go down, and eventually it goes down. And you'll notice when I'm moving this camera, I'm moving, but that sunset's not moving. When it gets to the top part of this meniscus, that sun starts moving quick, or that light starts moving quick.
Well, what I
this-
want to point out, just real quick,
Yeah.
and that's what you said, is that you've got a shadow at the bottom of the glass from that light.
Yeah,
Yeah, that's interesting.
yeah, and I think that could be the it's not something I researched. I'm just saying this could be a thought. It could be later in my research. I can see what that could be, but it could even be raw. It could be what's creating the shadow on the moon, creating those phases. But I'm going to play this video again that you can hopefully see how the sun is moving across this meniscus without me pausing here. Have a look here. It's just me showing you that it's not CGI. But it's crazy how that little sun is just floating around there. But now watch how slow it sets and rises. I'm still moving that camera. It's still there. It's still there. How crazy is that? Watch it. Slow, slow, slow. So this was a piece of the puzzle for me, which was it just fitted. So my puzzle is getting bigger. And my puzzle's fitting very beautifully, and it's looking beautiful. So
yeah, so the problem is that we want to get ourselves small enough to get on the edge of that glass and be in that field of view to see what the sun's doing from that perspective. But yeah.
So let's just make sure I'm going down my list here. That's angled ones. Okay, sky colors. So the next thing I wanted to move on to was the sky colors that is in folder 4. So I'm thinking, let me rather go to let me go to the sky colors here. So you most people will be aware this is actually a green flash that I'm going to talk about as well. But we do see the sky changing color. So there's been documented times I've actually got footage of it myself where the sky goes red, orange, sometimes yellow. I haven't got other colors myself yet, but I have been doing some research and the other colors do appear. But here's, for instance, a red color sky. I'll just touch on the green flash here, which is also going to come up in the next explanation why I think that is happening. And that's supposedly a sunset. It's supposed to be the tip of the sun, but we'll get to that as well. But that, just take note of the green flash, and you'll see a bit of blue there as well. Then we get a phenomenon known as the green sky. That's typically with storms. You'll get a green sky. There's sometimes where without the storm, the sky would actually be green. This is actually my own photo. This is a lightning strike. The next photo will actually be where you can see the lightning strike. I've got the video of this, but this is creating a purple sort of color, not on the actual sky, but you do. The reason why I didn't put a sky picture here, because I personally don't have a purple sky image. However, you do get purple sky images available. I just cannot verify if those are real images or not. There are different color skies as well, but those are the only 4 I've put in there for now. And the reason why I'm touching on these color skies is because of rainbows. And what I found was awesome is that I drew this in my book, these 2 drawings, and New Perspective posted a picture of the ancient. He found this drawing, and I said, wait, this looks like something I've drawn. I counted these here, and it's 1, 2, 3, 4, 5, 6, 7. I'm starting to think that this may be an old or a representation of the rainbow with this focus point going around. This is possibly, or this could also be the focus point. I'm not too sure what's going on in these two sections. A little bit more research into this. I just found it interesting that it matches what I've drawn. And he has that curve that creates that meniscus. But yeah, I'm saying that's the rainbow. Let's go back to my image. The reason why I'm bringing this up is here's idea 1 and idea 2. We standing in the center. This is that blue section on the previous drawing that I had. So this is our atmosphere. I'm saying that the reason why we see colors, or the colors that we can see or know of, is because of the rainbow. If I'm not mistaken, all the colors that we can see are all the colors in the rainbow, and I think those colors are above us. And the light, our light source, which I think is white, it's not yellow. I believe our light source is white, or light is white and darkness is black. But we're seeing colors because that's shining through these layers of atmosphere. I don't know what to call it. I can only draw it for you guys. I've got no science terminology in my vocabulary. So this seems to be drawn by I don't even want to call them ancients, but let's call them ancients. It's people that lived many years ago. They seem to have drawn the exact same thing that I drew myself. And I think these stars and moon is either going above us, which I will show two different explanations as well, or what I think is actually happening, or it's within what we've been told is a firmament. So either way, it can work. I do think that we are in an in-between model where the sun and moon move across us, straight above us, and the stars are circling around us, which I will show a little bit later, and the reason why I say I think that is happening. But that green sky, red sky, blue sky, purple sky, I think is something's happening within this atmosphere. Yeah, as the light comes through, I think there's different focal points depending on the conditions, which is why we are seeing a reflection of one of these colors, and these colors are in the order of the rainbow as well, which I've put over here. And I will show you an image of the rainbow. There's the actual colors. Oh wait, where's that image? Here's a real image of a rainbow, and I think we are seeing a projection of those lights coming down to us, and that's why we're seeing rainbows. You see sometimes circle rainbows, half rainbows, quarter rainbows. I think we are just getting a glimpse of that light coming through, and we're getting to a focal point or focus point within our own atmosphere, which is why you can actually get to a rainbow. There's footage of people walking through it. There's footage of people driving through it. So this is a focus point within our focus point. It's within our world. The world on that on the previous focus points I was talking about is a focus point we got no clue about. I don't think you can get out of it. I think we're trying to get out of it, but yeah, this is basically why I brought up the rainbow. I think this is how we're getting our light. I think this is how we get our colors, and this is just the reflection of it.
So, in a sense, you're saying that each of those layers in the rainbow are perhaps corresponding to a layer in the atmosphere?
Correct.
Mm-hmm.
So yeah, it's just what I observe and what I'm. It's what I'm seeing. Let me show you some. Yeah.
And the possibility that each of those colors is the result of noble gas.
So gases get excited with the electric field, but I do think light and electricity are one and the same thing, and I'm thinking it's a, yeah, like I said, I'm not that well versed on these terminologies, but it's a wave, so like a frequency, and that, everything in this world has a frequency in it. For instance, if you pick up a crystal, it's actually got a frequency, or you can resonate with that frequency. And the yogis, when you meditate, people talk about raising your frequency, connecting with your chakras, and I think that has got a lot to do with it, which is something I'm also going to bring up a little bit later. Is that?
Yeah, it's
Does
good
that
stuff.
on-
Keep going.
Cool. I did skip this by accident. I just want to show you guys a sunset here. So this sun, I'm going to fast forward a bit. Otherwise, we're going to sit the whole waiting for this to go down. But you'll see if I fast forward here, this doesn't set. If this was a round object, this would have a point in the end. This is flattening out, but you can clearly see the focus point in this image as well, which is why this is not actually setting. This is moving away from us. It's getting to that focus point. Everything above here is just a reflection, it's not a. It's a magnification of the lensing above the focus point. We cannot see through there. We cannot go there. The closer you walk there, your little circle view goes with you. But you can clearly see that sun is not setting. That is definitely not setting. Yeah, just a quick thing I wanted to show you. I am making a prediction that with that ether band video that I showed earlier on in the presentation, we will see a lunar wave through there, like Crow 777 has seen. Well, a few people have documented this now, but I think Crow 777 was the first person to capture a lunar wave over the moon, or talk about a lunar wave. I'm making a prediction that we will see one in the ether band on that focus, or just above that focus point. I am looking for it. I just need to find the time. This is about a year ago, just messing around with a few different experiments in my house, with basic objects, just trying to get an understanding of how things could work. So I just wanted to show this little video of it's a bowl of water. I will show the bowl of water now, or after this, and after this little experiment. But I tapped the bowl. This is just me showing it, the reflection. I'll show you how everything
Just real
works.
quick.
Yeah.
Beerman, this is your channel, The Missing Curve?
Yeah, it's something I did. I put a few little videos up there, but I haven't done anything from there yet. Again, I don't actually post much. I just save these in a location. There's a way for me to document, but now I've got a separate hard drive where I save everything. But yeah, that is basically my channel. But there's not much on there. Anyway, so you'll see I'm gonna tap the bowl of water. I will show you how this is all set up, but I tap the bowl of water and you'll see a wave come across the ceiling.
Can you make it large?
Oh yes, sorry. So this is the ceiling. I've got a bowl of water and my torch shining through the bowl of water, but you'll see that after this now.
Oh, I see. We're looking up.
Yeah. So yeah, it might be a bit too grainy, but there we go. There's that lunar wave. So I was just playing around with what could possibly cause the lunar wave. I was messing around with a glass of water, seeing if this is how stars could be formed. I'm just messing around, trying to replicate what I'm seeing when I look up. And it's fast forward here a bit. So there's basically my little setup that I was doing. A light source, a bowl of water. I was trying to eliminate the glass. That's why I kept it open top. But I'm still working on my way of trying to make experiments. Obviously, there's going to be some variables with this. What's up?
I said nice.
Yes, something I captured. This was it's also in early spring. Oh yeah, there we go. 9 September last year, where the moon was doing something very strange, and I'm thinking, because this is a reflection, I'm claiming it to be not a reflection or a lens effect. a projected image. I think something else was in front of that moon, and you'll see how it's flickering in and out here, and eventually the moon actually disappears. It was very difficult to capture this moon. I had to get my camera set up on the just above the wall, so I could zoom into the wall and then eventually see the moon. And you will see me zoom out here, but I'm not too sure if you see that flickering over that moon.
Mm-hmm.
So that I do suspect that's something happening with outside of that focus point ether band that we are seeing. But let me zoom out here just to give an example. So here is the wall.
Mm-hmm.
And that's why I'm saying it's so difficult for me. I do make a note here. I say I put it up to the wall. So yeah, I set up the camera to shoot above the wall because I couldn't find the moon. It was very, very difficult to actually get this because you can't see it with your naked eye. You have to zoom in to actually see this moon. Check out, it's disappearing. It's getting cut off. So yeah, that's just something I've been going through old footage, and it's something I remembered or reminded myself of. So let's just see. That's the moon acting strange. Okay, so let me go back to the image here. I'm almost done. This image here, where we've got the globe Earth model, we've got a flat Earth model. Then not a lot of people are aware of FPV Angel's channel. He's got another model which he's been modeling. If I understand correctly, he's been using a lot of the Book of Enoch's information and data that's been captured in that book to try create a model or map what how it was described to Enoch, how the world works, and he's done a fabulous job of building that model. So I'm following this model of his. I will also leave a link for this video of how he describes how the 12 gates work, how the sun goes through the 12 gates. It's incredible what he's done here. So let me just put the volume down here. So this is the way the map looks. There's a international dateline that runs on a globe Earth. Let me just make this bigger. There's an international dateline that's on a globe Earth, and it runs left and right of this map, if I'm not mistaken. And on the globe Earth, you will notice that no ship will ever cross that international dateline, and it's because they cannot cross that international dateline. If they do, they will end up on the other side of the world. Fantastic channel, highly recommend to go look at it. A lot of valuable information there. So I do, with my
Now you're
current
talking
finding-
about the dateline that runs on the Pacific.
Yes.
Mm-hmm.
Yeah. He explains these different waves. By my mouse, it shows how the light will run through here, how it goes to the different gates. It'll take too long for me to explain this. This is someone else's work. I'm only explaining my work. This is everything I presented here today is me. This is no one else. I'm not regurgitating anything. This is my work. Take it or leave it. I think there's something to be learned from what I am presenting here. But I think that he's got this map correct. Not 100%, but I think the idea of the way the sun moves over our plane of existence, which gets what I want to say rendered, what we can see is within our visual perspective, and that's till that focus point. Everything else out there still needs to be rendered, and only gets rendered when you walk closer to it. So you can map it, but you can physically or visually only measure what we can that's within our visual perspective, which is within from you to the focus point, or from the focus point to the focus point. But yeah, I just wanted to add this, that go check this out, because I do think that the sun moves across like this, and then our stars move clockwise around us, which on my explanation that I presented will explain the northern star rotation as well as the southern star rotation. If you do some measurements on the southern star rotations, you will notice that if you go from that center point to a specific star, it will be a longer line above than the lower part of that circle. So it's starting to squish, which will make sense on the personal dome, if you want to call it that. What I also found interesting was on NASA's website. Just see where I put that. Hold on a sec. Where did I save that now? There were these images. Sorry about this. Wait, there we go. This is one that was on NASA's website. It's a very blurry image. I actually saw it today. I just found it very, very interesting. Oh, wait. Let me just add this. That focus point ether band will also explain these sundogs that we see here. But what I found interesting on this NASA image with the sundogs, it looks like my model. I don't want to say I've got a model, but my idea. There's a guy in the center looking up onto a specific point. Yeah, I was quite shocked. I saw this today. I just thought I'll add that in. And then I just got a few final thoughts that I wanted to add here. I'm going to read it off because I don't remember that out of my head. So I just want to add here. I'm starting to look at So I am starting to look at high altitude images, the actual horizon images. What I am noticing is I'm seeing quite a big patch of white and then a blue, then blue at the horizon. This seems quite predictable in all the images I'm seeing. You're always seeing the same thing, and I think it's also got to do with that focus point, vanishing point that's getting reflected from the focus points above that focus point. After that, let me just change my screen. I see there are guys hopping into the sharing. Yeah, let me just open up that first image again that you guys can have a look at this again. So I was going to say another thing is that star trails. I've mentioned that. I personally don't think I have. I would say I haven't seen a real image of a full round Earth or its curve. I personally, after my research, don't think it's possible to take a photo of the full Earth if it is a big ball, purely because of this focus point and these personal domes around you. I think it'll just become one flat section. If you look at high altitude balloons, you'll see what I mean by that. You cannot see curve because it just won't be seen. So yes, our Earth could be a ball, but we can only measure to that focus point. We can't measure beyond that. If I am correct, and if flat Earth is correct, I still think it's possible to map out our world on a ball. So we will be able to create a ball, and you can see this documentation and the math done with the people before us. You can see they've tried to map it on a ball. So I think it is possible to do it. I just don't think it is a ball. There's no proof for that. I also think that they're hiding land on a ball. So we've been told we've seen everything. So we like, oh no, but we know it all. There isn't anything else to look for. So that's I think one way they are making us not look at these sort of things, because we know it all. Why should we look? And they bring out the CGI planets and space things for us to have a little bit of hope that there's more out there, and to not let us look on our own realm of existence, that there's anything else here. Let's just see here. One thing I wanted to add as well was the reason why I don't think the flat Earth, I would say, movement has been proven, or not a lot of people have really said, no, it's definitely flat or whatever, or there's people on the fence. I think that people are too hung up on word definitions and going down red herrings with bringing up gas pressure, gravity, things like that, instead of actually looking at, because that that's a give and take. Like it's a given. That's already proven wrong. Why fight the word now? The little tiny little things in between. Either accept you are wrong or you're right. And they're not. Both sides aren't accepting anything, and they're getting hung up on that. So if you have a look at the observations that you can see, build and test around that, and we can sort out the particle explanations, the science afterwards. And then we can confirm our predictions. But have a look around you, like what I'm just presenting here. Go look, you'll see what I'm talking about. You cannot see through there. We can work on what these things are called afterwards. Let's just go and prove to ourselves and go. You can clearly see that you can't see through these things. It is almost done here. Due to us not being able to confirm a globe, I believe they've managed to map the known world. I'm going to put inverted commas on a ball. Yeah, let's just see. Let's see. If you look into meditation, yoga, religions, etc., they all seem to perceive the world this way. What I presented, I think the Bible teaches this too. I used to be a Christian background. I was brought up Christian, but my findings do not come from the Bible. I just use the little bit of information that's in there to build on my little puzzle, and you will see you'll see it after viewing the world the way we observe it, the way I've tried to present my research and observations. Yeah, you'll be able to see why meditation is there and why it works, why yoga is there, why religions are there. It's all within my presentation. You can actually, they all tie up. And then second last thing I wanted to say is how I got here. So how I got to this was by listening to both sides with little to no knowledge of either side. I was taught it obviously in school. We laughed at flat Earth in school with the basics that everyone was taught, and then we had the planet spinning around us, and that's what we were taught. So I had very little knowledge of both sides, and I eventually fell in the trap of choosing a side, regurgitating, and then I got stuck and realized I was going nowhere. So when they debunked the globe and everyone was showing this flat Earth stuff, I just started believing the flat Earth model, and I was going nowhere. I could only regurgitate what everyone was telling me. So then I took the info and went on my own journey, and I started to rebuild the puzzle. I literally went back onto the fence and I started rebuilding my own puzzle, and with the pieces that fitted. On 13 September this year, I received a bit of information that I needed, and I put this all together, and I put the piece together that gave me an image that exploded my mind, and this is what I presented today, and it obviously still requires a lot of work. So lastly, my stance is I currently think the stars move over us like the traditional flat Earth map that we get, what we speak about here in the Discords, not that one that's floating in space, but the typical one that we see here. And then I like FPV Angel's model with the sun moving across us. That does appear to be on the correct path of how that could be working. And that is my presentation. I have it documented. I have all the images, the links. I will be able to share this. And yeah, thanks for listening. I appreciate it.
All right, thank you. Anybody who's in the stream right now, if you were able to watch the presentation, I really want to try to limit our conversation to only the topic. I don't want to talk about shape of the earth, proof, or blah blah blah, or this discussion that's happening necessarily with Hoymar in the chat right now. But if anybody wants to jump in, I know Alexander, you can talk on your own. But
yeah, I want to react. First of all, Beerman, I partly agree with you. I don't know if you remember, Travis, that I once sent you a very disturbed talk about the punch train image that I saw, and I basically thought that indeed in distance there is a buildup in density of water, and what I saw in there was basically what Beerman translates tells here, but I saw it going further past the horizon. So your placement direct at the horizon, I don't totally agree with. But another thing, Beerman, I want to encourage you to, as you say you are insecure in your wording, but you also say that you sometimes, and I totally agree with you, that there's too much word catching, and I want to encourage you to as much as what you observe, to make, if you need, a bouquet of words that describe it. I say it like that because when I have translated a Dutch flat Earth book, and that man is very talented in to look, and he used that method. And it's more common in Holland to do that, to make bouquets of words, than in English. And so your insecurity maybe lay it under the focal point of your investigation, to, as much as you can, describe what you see and not try to find a common term for it. So I would love to encourage you in that.
Yeah, and I think that's what we're going to do now in the discussion. We can try describe what we're looking at. I was just trying to get it to a point where we can all agree on a specific word to just name that thing that we can discuss. So that focal point, let's discuss what we think it is.
Yeah.
So
and to add to it, Jaron gave some attention to this translation on Globebusters, and he was very content with the translation because I put extensive attention to use the same kind of method that the man used. So it's I think I haven't spoken with Jaron about it, but I think I might conclude that is what he meant, that it's so well described what is happening sometimes. Okay, thanks.
Yeah, I think my main issue I have with the wording and all that is because I literally don't watch any of these, I would say, mainstream flat Earth YouTube channels. FPV Angel, I came across in my research of the Enoch books, and I came across his channel, and I was intrigued immediately, and then I took notes of what fitted with my discoveries and my observations, and I built my little puzzle pieces from that, and I'm telling you, my puzzle is looking so beautiful. I'm getting truths from everywhere. So, like I say, there's truth in movies. There's truth in the globe. There's truth in flat Earth. There's truth in everything. It's just you need to sift out the mess and put that puzzle piece back together.
So, if you wouldn't mind, talk a little bit more about the dateline concept. There's a little bit of activity in the chat. If you look in the chat right now, actually, Beerman, you can see a screenshot that I took of my marine tracker, and the dateline runs, basically down the middle. So you've got a lot of maritime activity there.
Yes. So if you, I'll see if I can find the video. But one of the ladies that are on FPV Angel's channel, she actually spent a lot of hours. I think it took her days, possibly weeks, to map the cruise liners that go along that do that route. and none of them, they always turn at that date line. So I think this data tracker that you have here is most likely getting mapped out from a either a GPS system, which is plotting it out onto a globe map. But if I do find, when I do, well, not if I do, I say when I do find that video, you can confirm it as well. So you can do that research yourself as well to confirm that she is not making it up. But yeah, like I say, that is not something I'm too familiar with. It's just something that I would say, for me, I fact checked it for myself, which confirmed it for me to be able to bring it up. But to be honest, I cannot discuss to actually talk any information about it because I'm not too familiar with the concept. I just do know that no cruise liner does cross there.
All right, so we've got Gary in the house, Dan the Waterman, Flatty the Arbiter, Tim. If you guys, Bacon's here. If you guys want to chat, just send me a link or a notice in the chat, and I'll unmute you. And like I said, if you wanted to discuss anything that you've heard so far, yeah, I'm gonna have to think through a lot of this too, because it's the thing that I think I was appreciative of was the meniscus demonstration. I think that was really, really interesting.
Thank you.
So I appreciate you having that insight to come up with a way to. Yeah.
One thing that I thought of back when I had that Lake Pontchartrain situation is that. And maybe no. Let me say it differently. I think that the water particles are just as us. If they can be lazy, they will be lazy, and so they try to stick as much to the field of inertia or the surface. So it's the thickest there. So if you then look into the distance, the first moment that the mirroring of the compression of the water particles through the compression of the water particles will be right above the surface, and it will be a little bit bigger. Just above, and then slowly bend a little, will become more gradual, if you understand. So you have that makes a kind of a meniscus right above the surface, if you understand.
Yes, actually, I didn't share those images. I'll post them now. These are the other three ideas that I was talking about with that angle. That I think this is what you're talking about. So let's have a look. I think it's the second image. If you open up that second one, is that what you're meaning? The actual thickness, density of that at that level? Is that what you mean?
I
posted in the live stream.
It's in the chat.
But we have talked about it now, Beerman. I will open it. I will make some illustrations and open it to you. Okay.
Perfect. Yeah. Perfect. Thank you. Like
Okay.
I say, I'm new to this. This is just my personal research and pieces I'm putting together. And I just had I would almost say a calling that I had to share this because something was drawing me towards sunsets the past, say, 4 months. And then I had an aha moment when Dan the Waterman spoke about geometry with the sunset. And yeah, that was just that bit of information. Was that little piece of information that confirmed for me that we can't see beyond the focus point, purely because you cannot confirm that there's anything past there, because sometimes we like you see with that boat, that video I played, that boat's just going straight into that focus point, and it's staying in the same place. Those those people are walking on what I call a treadmill. They're going nowhere. So we can't confirm what's beyond there. You can't measure what's beyond there.
Speaking of Dan and the Waterman,
Travis, I have so many things to ask you about.
well, it's not my presentation, so Beerman's the one to ask. Were you able to catch anything?
No, just
okay.
the feeling that he had. I missed it, and I was lost with the other stream trying to figure out where you guys were.
Oh, okay. Well, it's
So-
it's on my channel if you want to go back and watch it. But
Okay, great.
he did say that something you said about the sunset and geometry. So I don't know if
Yeah, I wanted to ask you about this both. I keep losing people. See, I got lucky with the panel saving me on that because I had support. Alone, I wouldn't have had gotten to this point. Fortunately, he repeated himself over again about the boat and the sun sharing the horizon. When I continued to talk to other people, though, I get lost after that. That's the zinger. When they admit that sun and boat share a horizon, I'm done. I'm telling.
you're breaking up, Dan.
Yeah, you broke up there, but
Yeah,
But
Dan.
it-
I don't know if you're. I'm sorry, just real quick, Beerman. Dan,
Edit.
you're breaking up a bit.
And I
We,
keep
we
using-
lost.
Word, the angle has been reduced to 0 for both objects. Crap. How about now?
You just came back in right now, so if you were talking for that entire time, but right now, I don't know. Are you on push to talk, or is there a way that you can?
No.
Yeah, you dropped out again.
yeah, he's dropping out. But I think what he's saying with the, let's see, let's unmute him. Let's see if that's better. Go for it. No, I'm not hearing him.
Yeah, just put him back on mute.
Any help? Any better?
Go ahead. Let's see if it's better.
All right, I have an awful connection, right? This didn't.
Yeah, it's not working, Dan. You're nothing's. It's all staticky.
Oh, let me add. I think what he can correct me if I'm wrong, but he was talking about a 0-point angle, and that's where he's saying the boat and the sun is meeting at the horizon. So I sort of agree with that, but I still believe that with my research and my observations that there's that focus point where the two images meet and the camera is picking up that focus point, which is that ether band, and we're not seeing beyond that ether band. So we're seeing a reflection or projection all the way above us, around us. And that explains how we see the moon and sun that's actually looks close to us, but we won't know the distance of that unless I can start putting some experiments together to be able to predict when the focus point is at a certain distance. I'll be able to predict how much magnification we'll have on that day, and then we can do better calculations and observations of where that sun and moon may be. But that sun definitely does not set, and the boats definitely do not go over the horizon.
So you guys can hear me now, right?
Yep. So
Yeah.
far, so good.
Great. So this point where both things disappear, I keep using the word that the angle, when they keep talking about the sun and the sun is already set and the boat is already gone, I keep telling them that our angle as an observer has reduced to 0. And in other words, right at the point where I get them to admit that the sun and the boat share a horizon, whatever they're calling it, that's the zinger moment, but I need to tell them it was the zinger moment. And I have trouble explaining that once over the horizon, there's no longer a viewer angle. And I think I keep using the word angle and confusing them. And I say, well, it's reduced to 0. You could no longer see it. But that angle isn't 0, and I don't think angle is the right word.
You know why that
Do you know
is?
what I'm saying?
Yeah, you know
Why?
why that is, Dan?
Why?
In a side view, an orthographic side view, you always have an angle, so you have a number. And because you want to keep calculating, and I'm talking about Globers, they want to hold on to that angle. It's a number. It has substance for them.
So when I say the angle at sunset has reduced to 0, I know that's not proper terminology.
No.
What is it? A vector? What is it
Well,
that's changed?
Well, basically, it's like this. Then, supposedly, the horizon is at an angle of 0.02 degrees, right?
Thank you. So I am using the right words. Thank you.
Yeah.
Thank you.
And when you have smaller angles, there is only 1 or 2 pixels where it can be projected on. It doesn't have details. It doesn't have any variation in color. It has to be 2 or 1 color, and that's it's almost impossible when you step back to see these 2 pixels. Even if it's still 2 pixels, you will hardly be able to see it and to see it diminish. So but on a side view, you always have the same height, and you always have an angle. So you have something. You have a number. You can calculate it. You can measure it.
That's what I'm saying too. They need to. And the next time I do an observation with the boat, I'm going to make them predict the horizon to begin with. Make them take their stupid measurements of temperature and humidity and try and predict where the horizon is, and then we'll take the boat out there. But they ask us details at this point that are completely flexible and impossible to place back into your data set. It's like, well, what did you have for breakfast? It's like, what does that have to do with anything? It's like, well, what was the temperature yesterday? It's like, I have no fucking idea. I think sometimes they just get excited when they come up with another question. I recognize it now. They're just coming up with a question, and what do we call that? Straw manning?
Yeah.
Just real quick, Data, are you there? I unmuted you. Okay.
I just wanted to add quick. I just want to add that in South Africa our power they switch our power off for certain periods of time. So I'm currently on my inverter and battery.
Wow.
But the power should be coming on in the next few minutes. So when it does come on, I'm just going to disconnect for a bit so I can switch back over to the main power. So if I do disconnect, that's the reason. But I will be back.
Travis?
Sir?
I want to give you a little bit of credit.
Well, thanks. I appreciate that.
Well, I've never, had clarity with your stuff. And I never thought I would be able to teach anyone. Beerman and a couple of people got really excited with that Ruhif thing. And I just can't believe how basic it was. And I'm wondering... So where we're at with this is they're going to claim looming refraction to bring something up.
Right, you just dropped out then. We were, yeah. So we
bad reception for 2 days.
We heard you say they're going to claim looming, and then that was it.
So they have to stick to refraction and looming to explain a distant sunset. They have to. They don't have a choice. I think now we can really go after refraction in terms of mathematics. And if we start to change our observer height and show that there's no math involved, that there is no angle change, that the weather doesn't change it. You know what I mean? Like they're full of shit. is what I'm saying, and we need to make them predict and measure refraction and stop just saying it. In other words, it's not
Yeah, I
a
agree.
word.
Yeah, I agree.
There's formulas behind it, and it doesn't achieve the things they do. Yes, it does exist. So we
Right.
need to switch. You and I need to switch to admitting refraction exists. It's like we have to admit it exists just to go forward, but they have no explanation for the range of, let's say, something coming into view both 50 and 100 miles away by the same formula. It's not going to happen. So first we need to have them predict where the boat, we need to put them to work in their math. Otherwise, because this is what they demand of us. So everything is just going to be a reverse for me now. They have to show a prediction. They've got to measure the weather, the temperatures of the water, the temperatures of the air, the refraction index, the weather, the humidity, and try and chart that somewhere into mileage before we even get started. And then I'm going to take that boat out to that point. And of course, it will not have disappeared. And we got to do it on the day where the sun is still back there somewhere else. So I think that's the first part of refraction killer. The second part is going to be what I'm now calling force the light. And force the light is the lateral test I've been talking about. And I got the pixel strength. At 10 miles, I got the pixel strength where if we got a 60-degree wide view, I've got 8 pixels to play with. And that's enough out of a 100-pixel image that we will see the curvature of the Earth if it's there. So I'm just going to light up their stupid Earth and let them analyze it. Tired of making claims. All we have to do is clearly show what we're talking about. Unfortunately, for years you've been unclearly showing an unclear area of the Earth, and you're dealing way more with things that aren't refraction when you shoot. Usually, you have way more temperature inversion, way more wavelength of let's say wind and heat. All the inversion and mirroring that you're dealing with isn't exactly the same thing as their refraction. You know what I mean? Their refraction is, and when they're talking about lifting something up that far, is got to be under a different range. Travis, what is this 0.3 or 0.03 number that they use as their maximum refraction? What is that?
Oh, I don't even know. I don't even know that I can say that I've heard of the 0.3 per se. But just real quick, Dan, because Data did join and Beerman is back. Data, did you want to bring something up?
Oh, I was just curious about going from one model to another model. I mean, they have to have consequences in thought, obviously, but also in how you perceive reality. And your fellow clergymen or whatever, I'm just curious to know why he went and adopted another model right away when they tell you that the tools we have are limited. And if we're going to get outside of that limited tools, we're just going to use abstract mathematics. And it's just kind of jumping on the train again of the same thing that you're leaving behind. It just sounds kind of funny.
Are you talking about something that Beerman said?
Yeah, just regarding his jump from one train to another, right? I'm going to jump off this train and jump on another one. And for sure, this unseen, unprovable, unfalsifiable claim here is what I believe. It's just going from one unfalsifiable thing to another, albeit there are evidences and proofs that could maybe lend to one model or another. It's still jumping from one train to another.
Did you hear anything? Did you hear anything in the presentation that wasn't as shaky that you appreciated?
I didn't catch it. Majority of it, I probably caught maybe the last 5 minutes, if that.
Yeah.
And
Okay.
it's again, it's just I know Blender, I know how to use it. There is no way to model. You can use refraction to model opposite rotations, but if you put an object along that path when you refract it in the modeling, it doesn't change direction. This is what you know, the conundrum or the paradox here is for me. Anybody showing me a model.
Okay.
Yeah,
Beerman, yeah, you've
yeah,
got. Go ahead.
yeah. I'm going to respond to Beta now. I just wanted to add, this was the other, I forgot to show you, was the other picture I got from NASA's website, which is funnily enough similar to what I presented with not using any of the information. It's just something I saw today when I was searching sun dogs. And it's weird that they're using this representation, which I showed today. And like I say, I didn't get my drawings, my measurements or anything from anyone else. These are my observations that I was doing, and it's just funny enough to see this on NASA's website. So I'm not looking at their names and stuff. I was just looking at the drawing and representation that they're using, showing the sun on the actual ether band or whatever we want to call this. I just found that very interesting and sort of proves my point again that it goes all the way around us from that focus point. And beta, however
No,
I say that.
it's data.
Oh, data. Yeah, I'm not presenting a model here. I'm presenting that we can only see to that focus point, and we can measure and map out what we can see within our, I would say, visual spectrum, or how do I say this? But what we can see, what I presented in the beginning, to that focus point, so we can map till that point, and then we can go from there and map the rest. So there's definitely not a change in model going on here. I'm just I'm presenting something that is quite clear that we can't see past that point. And then Lightwater mentioned something about the infrared that can see through it. I'm yet to see infrared footage that has seen through it. I do see that focus point in infrared footage as well. I most likely haven't seen enough of it. So if we can get more footage of that, that'll be fantastic. But I am yet to see infrared footage see past the let's call it the ether band, that was lens that I was presenting.
Hey, Lex, do you have any examples that you can show us, or what have you?
Well, not explicit. There's not much real high quality infrared photos as far as I have seen. I have seen Exploring the Plane. I've seen Tolan Media. I've seen the one from Blackpool to the mountains. I have seen the Canigou, and I base my observation, my thoughts about it on that, and I see that mostly the reflections are disappearing, and not the refraction, and the refraction is small in the infrared observations, as far as I can determine it. So that's my take on it. There should be many more observations to make a definite conclusion.
Okay.
But I have seen enough to mostly the water is totally black, and that suggests that reflections are disappearing. So
yeah, I've only ever used the infrared that turns everything pink.
Yeah,
so I haven't.
Yeah, and that's not good enough. That's not good enough of infrared.
Okay.
Yeah.
Huh. Okay.
I put this picture up as well on my screen share. It's a little truth that I saw there as well, which I found quite funny. It's a little funny picture with how to keep zombies out of your place, and they're all walking on the treadmill, and it sort of ties in with that treadmill video that I showed you with those people walking on within the lens, and they're walking and walking, but they're walking in one place. It's sort of telling me that they can't get in and they can't get out because they're stuck on that treadmill. So I thought that was quite fitting.
I have a different explanation for it, because it's a rather acute angle, and you
pull that video up again, Beerman, if you can.
You see basically over a long distance they're
gotta-
walking and they're walking only at walking pace, so it might appear that they stay on the same place, but they are walking forward, and because of the acute angle, it doesn't seem to go very forward.
I'm going to disagree there, unfortunately, because we have done a test on the road, and you can, if you have a look at, let me rewind here. If you look at the yellow marker on the right, they stay next to that for quite a while in that same spot. I've done a little test just to see what would happen in a similar scenario without this happening, and you'll see distance, the actual person getting some distance, gaining distance, but in this one it doesn't happen. The cyclist as well sits in a place in the same place for a while, but you will notice there's different lines in this footage as well, which is I'm thinking that there could be multiple lenses within this lens,
Right.
and
Yeah.
we're getting the focus of that one lens. So sometimes you'll notice that they hop to a new spot, and then they hop to a new spot, and that's telling me that there's different lenses that we are seeing within this lens. And I think it's due to that heat. So it's really messing up the atmosphere in this location, which is creating these multiple lens effects.
Yeah. Mila's got some good footage.
Yeah. So I think that explains what you were questioning now or saying. But they definitely walking. Looks like they're walking on a treadmill.
All right. Well, anybody have any last parting thoughts?
Yeah, I want to shout out to Ben, Taboo Conspiracy. He's been a fighter like you for a long time, and he's
Yeah,
owned
definitely.
like you for a long time. Shout out
Definitely.
to anyone
Yep.
that's having to do this without the support of fuckbusters and all that shit. Because it's really been a hard time dealing with bullshit at the top, and having nowhere to share things with the community is really tough. So
Yeah,
thanks for
yeah,
all the
definitely.
work you've done. Thanks for the work you've done to always share what you've done and to feel a sense of community, and that's outside of your spiritual journey and and your feelings. So thanks for being as scientific as possible, because we need it.
Yeah, man. You too. As always, all of us here. Data's got some fantastic insights. And he looks at things in this discussion far more technically than I do, right? So we all need each other. And Dan, what you brought up this week in terms of the sunset was something that I had never thought of, and really enjoyed running that through the old gray matter. So thank you as well.
Wasn't it bizarre how it was sitting right there the whole time?
Yeah,
We never
sure.
mentioned it. We never even mentioned it. But I
Hey,
think
Travis,
this is
just out of curiosity. Sorry to interrupt. Man.
no, just that, like Beerman said, it is measurable. The things we're talking about are measurable, and that's great. We just forced them to do it. Force them to produce those numbers.
Hey,
Thanks for your
Travis,
help.
on the distance, on your average distance, or when you've taken your images, what is the average distance overall? Do you think you tend to hit with your camera? 10 miles, 16 miles, 5 miles?
Yes. I mean, look, where you're looking at
There
right.
has, sorry. Let me just finish before you continue. What I mean is what is the? Do you max your camera out to get the effect? Are you mid telezoomed, or are you max focused? Like you're fully zoomed in.
So what you're looking at right now on the screen, if you can see what Beerman's showing on one of my videos, this is about 3 miles away, and it's right at the place where the band is beginning. And this is going to be full optical zoom on the camera. But on the Chesapeake Bay here, I've got targets that I shoot 1 mile, 3 miles, 6 miles, 9 miles, 12 miles. So it's just a matter of magnifying the target. You know what I mean? What would be interesting, I think, in terms of what you're talking about, and even what Beerman is saying, like, if I'd have to go back and look at footage where I've panned from this spot all the way across the Chesapeake Bay, if I kept it at the same focal length, because then you're going to see the distance come in and out, you know, and you're going to see the band affecting that distance each time.
So you do have
Yeah,
a video.
fair enough. So what I'm looking for is what they've given us for numbers already. For instance, like a lot of the fraction calculations are actually done with that square root of the observer's height multiplied by 0.96. If you look at any of the books, anyway, for navigation or whatever, that's what they're going to claim. So you're an average what height off the ground?
60 inches.
Okay, so you're almost 6 feet, right? Or you're what, that's 5 feet?
Yeah, 5 and change.
Okay, so I was working out a calculation for it because all of the other formulas for this effect is using the square root calculation. That's all I can see, right? And the hypotenuse is a straight line. It's not a curved calculation. It's just a deduction from a straight line. So you can either claim that that's a drop from a present point, or you can claim it's refraction. In this case, in nautical almanacs, they claim it's refraction effect. It's not claiming to be Earth curvature, right? So what I've estimated is that 0.96 divided by 60 divided by 57.3 will get you the radiance value, and then you multiply it by the distance of your observation. Will give you, 4 to 5 feet obstruction based on that refraction calculation. If we're just going to use that straight linear information, right? Because the calculation for the square root is an exponential function where you get that exponential rate calculated in, right? So 1.22 plus 1.22 plus 1.22, so forth. You know what I mean? When they square the function, right? So I have a formula for you, is my point. Sorry, long-winded here. To apply to your observations, and what I've calculated is, on average, about 10 miles, you're going to have about 5 arc minutes of refraction, which will equal whatever, close to or whatever apparent squared calculation you get. But that's directly related to the concept of refraction, whereas the other one is conflated as Earth curvature. Do you follow me so far?
Mm-hmm. Yeah.
So in other words, the square root calculation is considered to be Earth curvature calculator, but it's not. It's actually based on refraction.
Right.
So I've decided to see the parallels between.
How would you go about, I guess, proving that in terms of separating the two topics and just showing that what you said can apply to refraction entirely, so that, let's say there were no globe talk, we would just understand it purely in terms of refraction? Is it just as simple as saying it that way? That, look, these are the values, this is refraction, these are the values for refraction.
Well, in a sense that I'm drawing it that way and implying it that way, and it's related to taking your, the arc minute, which you conflate to as refraction. So it's going to change directions 5 arc minutes, right? That's the concept of it. So
well,
when you
keep
break
thinking
that
about
down,
think about how you could create an observation to be carried out, to maybe.
Well, that's what I'm saying. I have a formula for you to apply to your observations you already have.
Okay.
And what I've already deduced from some of the observations, my own, is about average of 10 miles, you have a 5 arc minute of refraction. Now, here's the thing, is I didn't get that 5 arc minute of refraction. I didn't make it up. I actually read it in other material. And so what I tried to do is back calculate it. So for instance, you take 5 arc minutes divided by 60. It turns it into degrees, divided by 57.3 turns it into radians. And then that radiance, you multiply it over the distance of the observation. And in this case, for a globe model, it works great over 10 miles for 5 arc minutes. You get that, well, it's 76 feet, and the globe model is 66 feet. Now, what's the bonus about this is if you can estimate how much arc minute of refraction it is, well, you'd be able to multiply that by the height of the observer and get the distance to the horizon. right?
Well,
so that's the bonus of the formula is you can take the observer's height, multiply it by the refraction calculation to get the distance to the horizon, right?
so I guess the only thing we could do in general is just look at a photograph and the distance to the target. You know, like if Beerman, if you want to pull up one of the stills of the
Yeah, actually, I had one ready to open here
red
after
roof
this video.
house.
This is the one I wanted to open. Is this the one you wanted?
Sure, that's fine because you've got
Yeah.
unobstructed and then you got refraction. You've got mirage as well. So can you see the screen, Data? The share, click the live.
We know that this is a great example for applying the concept of refraction and the calculation for it solely because of all the multiplicity of opportunities that it shows you where refraction changes. So, for instance, these observations in total are how many distance away?
This is 5.87.
So 5.87 miles.
Correct.
Okay, so if you knew if we could take a drier day and start estimating. Well, first of all, you'd have to know a little bit of humidity and so forth, right? You'd have to know some variables, pressure and humidity. But if you got a drier day and you can try the base calculation of refraction, which is 0.96 or 1.22, these numbers are great for first base. But the refraction is just going to give you a variable that's relatable to the hidden or obscured. So if you had a portion of the image obscured bottom up, you could estimate how much of that is refracted, that apparent hidden position. Do you follow?
I do, and like I said, this is where I would be like, yep, you can go ahead and do that one. I'll take pictures.
Well, this is what I mean. Like, if you had each image presented with, I guess, see, the thing is, you now have to get this K constant, which is already derived from, mathematics, or they're already derived from the science, if you will, model, the globe model, if you will, that gives you these variables over a distance, right? Like, again, it's not something I can
Can
do
you
100%.
can you see the screen though? Can you see the
not
screen?
very. I can see it, but I'd have to. Yeah, I can see it. I mean,
Zoom in,
like,
Beerman. Zoom in on the far left one.
see, all these observations are within, obviously, within the focal limitations, right? You're zooming in, so you're not going to get. You're going to get some effects, I guess, but if it's just water, you're going to get more effects of it, right? Than just land, or what would you think?
Well, I don't know. I don't know what you're saying right now. So all of these images, if he were to pan through all of them, they're all the same focal length, and they're all they're all the same viewer height. So this one right here is a great, the one with this mirage. You know what I mean? So, like, how would you?
Yeah. So
Okay.
what would be the point of understanding observation? It would be the effect is refraction, or what we deem as refraction. But what would be the point of this picture to calculate the effect of it hidden? Because again, we're trying to use an argument where objects are hidden bottom up, either due to Earth curve or refraction or a wave or whatever variable the ocean has for that day. In this case, the application is for what? Like, what are we trying to apply a calculation for? Like, I have a refraction calculation, but it's over a distance of
I
something
would
being
say
obstructed.
the way that I would answer your question is the degree of the angle of the mirage is equal to the distance it covers.
Well, what is truly obscured, I guess, and they're all the same focal length? No, they can't be all the same focal length.
They are, bro. They are, absolutely.
Hold on, Hunter. You're moving around for me, okay?
Yeah, I was just going through the different pictures. Yeah.
I can send. I can put the. If I think about.
Yeah.
it,
Okay. So what do we want to calculate for? What's the point? We understand that there is an interference in the image. We're looking at this looming effect, but this is not, to me, to discuss any curvature or anything at this distance is sort of like bizarre, right? Because you've got a mountain behind you, or a hill behind you. Do you know what I mean? So, what are you trying to analyze here?
No, again, so this is. I'll say it again because I do think, unless and if it's out there, I haven't found it. Okay. the image of the mirage is not vertical, even though it apparently looks to be directly below. If we were to pull up a mountain lake with a mirror of a mountain peak in the distance, the mountain peak reflection on the water looks as though it's directly under the mountain, but it's not. It's across the surface of the lake, just like the shadow of a tree is not directly underneath the tree, even though it apparently looks like it's just vertically there below it. It actually stretches out toward the viewer across the surface of the land. Now, as far as I know, no one else is making this claim about the mirage, and it's the same thing. This mirage is stretching out toward me over, it could be 3 miles.
Oh, I agree with that 100%. This is what I've described before, that effect that you're seeing is taking that distance of water, and because it's foreshortened, increased you would never really see this with the human eye, right? With the detail.
Right.
And what you're doing is you're zooming in, creating a foreshortened effect, that distance plane of the water spreading out, creating a mirror effect. So you're I don't know if exasperation is the word. Your camera is adding to the illusion, right? Because of the foreshortening effect of that light that is mirrored or in my case, I see an energy exchange. That energy exchange there causes the mirroring, and it affects the way we perceive it. And when you zoom in on it, it compresses that light even more, giving you that crazy illusion that it's looming up. And then you also have wind patterns too, right? Wind patterns change the effect of this over the surface of the earth.
Well, I
too,
don't
right?
know, man. I don't know. So much goes on while I'm shooting. There's wind, there's no wind. I remember when when I was on the side of the house, on the Chesapeake Bay, I was on that side shooting back, and my friends were on that side, and I said, "Oh man, it's really windy over here," and they said, "It's not windy here." So you've got wind on one side and no wind on the other side, but what that does, I don't think anybody knows. I don't know, man.
Well, it's messing with the light, right? For sure. The light, the way it comes out of the water. I mean, without water and wind, you probably wouldn't have this effect. Why I say wind is because it would be a temperature inversion to either warm or cold.
Yeah, but see
that's what we've already done tests like that, right? Like there are garage tests you can do. We've already seen them. I've done them myself in the warehouse where you can get this effect very easily just due to the wind.
But see,
over this. Hold on.
Well, hold on.
The wind,
okay.
just with the wind going over the surface, right? And if that wind changes, then that effect goes away. But here's the thing: not only the wind, the angle to the position of wherever that wind is crossing over the surface. If you change that angle, you can change the effect as well, right? So I've directly.
Are you equating the air coming into wind? Because I don't know that I would call those the same thing. Although I can see that.
In the example of the garage floor, if you have a warm floor and cold air is coming in, and you can have a good stretch of 200 feet, 300 feet from that observation, you can create that effect on that floor, but you can't see it at a certain angle. A camera has to be positioned down low enough to see it, and the effect is just wind. In this case, air, wind, whatever you want to describe it as, a fluid, a cold, fluid, dense air is coming across that warm concrete floor.
Well, here's where I would throw the monkey wrench in, and that is I would set up a fan across the field of view. So once I open the door, everything stabilizes, and then I turn on that electric fan and see what wind does in the cross pattern.
Well, I've just done it where you know directly that the cold, dense air against a warm surface will create this effect that you see. Mm-hmm. And that's one driving factor. It's just an energy exchange. There's no electromagnetic stuff that I see. There's nothing I can test for. Now, what I haven't done is done it with different light, per se, to see the effect, but I imagine that it's still the same because visible light, if it didn't, visible light would be incoherent. Visible light would be coherent. And it's not visible light's incoherent, which means that they all work at the same level with our spectrum of vision anyway.
Gary, did you want to jump in at all? Gary Webbing is here as well.
Yeah, I like what you said a minute ago about the mirroring thing, because I can see the reflections in the mirages on the road of cars way up ahead. So that foreshortening effect, if you get lower, cuts off that distance, and it can make it look like the car is like right next to it, when in fact it's way off.
Mm-hmm. Yeah.
You got it, man, for sure.
Yeah.
Yep, it's compressing everything.
Pressing, yeah.
These are optical illusions due to refraction. I mean, the effect that you're using in telephoto zoom lens is using the refraction of light, which the only way it could work in the manner that we're seeing is if it does travel parallel and straight to the lens. That's the fundamental principle of observing these things. And if you want to see a greater effect, observe it over a greater energy exchange or temperature inversion. So I can demonstrate temperature inversion, and I can demonstrate optical angles, reducing and increasing the effect. So those are the two things that I have control over in this observation that prove to me that it's not mysterious as much, but to calculate it's challenging. Yeah.
Also, you mentioned how sometimes on the distance it looks like a person is walking in place, right? Well, you get the same effect up in the sky with an airplane that's high and far away.
Oh yeah.
Compared to, it looks like it's barely moving, but when it flew right directly over you, you have a completely different angle to it, and it looks like it's moving fast, right? And and I think that also is why we see the sun just hanging there towards the sunset, where it doesn't seem like it's going down, which is a problem for EQ mounts, because Wolfie has a video, and him and Bob actually did one together, and they were showing why the EQ has a problem tracking sunsets, because the EQ wants to point down like the sun is going down, when in fact it's just simply staying in place because it's moving forward in that foreshortened area, so it doesn't look like it's moving. So
yeah, I don't know if you saw. I don't know
Go
if you
ahead.
saw this or just real quick, as it's on the screen right now. If you weren't here for what Beerman is showing right now, this is exactly what I was thinking about based on what you just said. So if you want to take a look at the screen, did someone else want to say something real quick? So what Beerman's showing is that when he gets to the edge of the meniscus, the speed of the light reflection slows down and hovers and stays there longer.
Yeah, I'm looking at it. I'm having a hard time seeing it. I'm
Oh,
on my
actually,
phone.
Yeah.
I can upload the image here as well, or the video.
Yeah.
Sorry,
Yeah,
and
you can always
also
go. You
I
can always
used
go
my
back and
left
look at it.
hand. And, yeah, I was using my left hand to film with the one camera, and yeah, so it's a bit bumpy, but yeah, you should be able to see it. I'll post it in here. I'll play this again.
What I like about what you guys have all been saying is like you guys all have a good ideas that we don't hear the other side talk about. In fact, they avoid like the plague. Because a lot of these things we're talking about is really, it's their imaginary curve.
All right. Any last thoughts?
You should write this down just for shits and giggles, and see if you can apply it to any of your observations for looming. And because the idea is that it's a deviation from point refraction, right? So if you have a straight path, it's going to deviate. In this case, this mirroring effect is sort of like internal reflections. It's a position where light is passing at an angle, a critical angle through the water to create the reflection part, right? The interesting part is how does weather or temperature inversion create it, essentially, because in a fish tank where they studied internal reflection, it's just an angle of perception. So does the cold, dense air interacting with the hot concrete floor stretch out the energy, if you will, or because something gets excited. What's getting excited to cause the internal reflection? That's how I'm thinking of it anyway. But do you know what I'm talking about? The aquarium internal reflection of water at that critical angle?
Yeah.
So that's cause, like the fish tank is causing that, or I shouldn't say the fish tank is causing it, but the angle at which we see the fish tank hold the water, we can see that internal reflection. And what is that? What is that necessarily? That's not a temperature inversion, is it?
Well, it's almost
That's-
like this. It's almost like I just thought of this right now, based on what you're saying and what's on the screen right now. You know, when you get, if you hold up your, if you have reading glasses or whatever, or even if you had a quarter-inch plexiglass, you put your finger underneath it, your finger will look like it should come out the other side, but it's now your finger's cut off. So it's almost as if, and if you had a corner piece of an aquarium, those two glass panes come together. At that point of contact, you're going to have the internal reflection where it's going to get swallowed up. It's almost as if at this point on the surface of the water and the vertical landscape in the distance, when they come together for the inferior mirage, that's the two panes of glass coming together in that place of internal reflection, right?
Right. Yeah.
That's
Well,
interesting.
then
Yeah.
you don't need when you look at the internal reflection in an aquarium, it's not due to temperature inversion, but when you look at a mirroring effect on the concrete, that is due to a temperature inversion. It's interesting, right?
Yeah, I've never done. I mean, I've only seen demonstrations of the internal reflection, and it's always in an open, I guess, an open field of view, so to speak. I don't ever see it as a place
Well,
of
just take an aquarium and look at the bottom of it, not just around the edges, but underneath. You're
Mhm.
gonna have that beautiful reflection going on, just as if it's mirroring, right? And that there's no temperature inversion happening there. That, well, maybe there is. Maybe at the surface there is, and that's the effect at the surface. It's exciting something, and therefore causing that critical angle. Because it is angle dependent, right? That's why we can raise and lower, and we go up high, it disappears, we can't even see it. Doesn't matter how much energy we put there, but we get at that critical angle, which I don't remember. I think it's 48.8 or 42.8. I can't remember the critical angle, but that's apparently what it's classified as.
All right, so I'm just thinking it out loud right now. Again, going back to my two corner pieces coming together. If you have a Fresnel lens, or if you go and buy a
see that
rectangle-
observation on your screen? You see that observation?
Hold on.
That's false.
Yeah, hold on, just real quick. Let me finish my thought because I'll forget. So if you have the Fresnel lens at the edge, you're going to get this refracted distortion of the image. It's gonna distort and bend, like the demonstration that's on the screen right now. But if you have another Fresnel lens coming from the top part and coming together, then you're going to have both those Fresnel lenses merging with, and that's what I'm just going back to what I said earlier before about the possibility of an inferior mirage. You've got a horizontal corner or a horizontal edge coming together with a vertical edge at that critical point, together creating an inferior mirage. I don't know if that makes any sense, but
Well, it's definitely an optical illusion, right? Because as soon as we change our optical position, the effect changes. And just like in your demonstration here, it would be false because I've done this demonstration in Blender where I've made concentric circles like that, taken a half refracted sphere like that, and then ran a course of objects. Even though it will look like it's separating from the edge and creating two apparent rotations, the bodies that go along the path won't change course. So it's this here is a misleading representation. You cannot model opposite rotations with this effect.
All right. Well, there was a nice pregnant pause there. Beerman, thanks so much, man. It's an ongoing discussion, bro. So keep it up.
Yeah. Thanks, man. And yeah, thanks for giving me the time to present it all.
Yep. Absolutely. All right, guys. Thanks so much for hanging out, and we'll catch you in the next one.
Later,
Cheers,
Travis.
cheers.
All right,
Bye.
bye.
You know, what I'm starting to think is that the Earth is 25,780 roughly miles. They're cutting off at a good chunk of it, like maybe 1,500 miles worth of land.